In today's objective, we're going to be identifying characteristics of quadrilaterals. Our two vocab words are vertex and line of symmetry. So a vertex of a quadrilateral is either the highest or the lowest point on a parabola. So we know that parabolas curve upside down or they curve facing up. So our vertex is going to be the highest point or the maximum on a parabola that opens down, and then it's going to be the lowest point on a parabola that opens up. The line of symmetry is a line that divides the parabola into mirror images, and it's a vertical line through the vertex. So if I have my parabola and my lowest point, which is the vertex, the axis of symmetry just kind of cuts the parabola directly in half. So if I were to fold this, it would be a mirror image of itself. It would match up perfectly, and it does pass through the vertex. So here we have this graphic that kind of lets us play around with the coefficients of a quadrilateral. So I can choose to just focus on this part of the graph. I'm going to leave my B equal to 0 and my C equal to 0. So I really just want to see how the A is affecting my graph. So if I push it up to a positive value, there we go, a positive A curves up towards the top, and a negative A all of a sudden brings our graph down. So just by moving around our A values, we can see that it gets wider when it's less than 1. I have a pretty wide parabola here, and then the closer I get all the way up to 3, it gets narrower and narrower and narrower. And same thing when I'm in the negative. I get this wide negative parabola, and then the closer I get to 3, I get a narrower graph. So if we were going to talk about how our A impacts the characteristics of the graph, the sign dictates if it opens up or down. Right, so a positive A, I'm going to have a graph that opens up. A negative A, I'm going to have a graph that opens down. And then the value of the A shows how wide or narrow. So an A that is greater than 1 is really narrow, and an A that is less than 1 is wide. And less than 1 meaning, I guess we could say, absolute value, because the negative, we already know that we're talking about whether it opens up or down. So it's really just the actual value of the A. If we have a number, here we have the 3, makes it very narrow, even though it is less than 1. And this is in comparison, the narrow and the wide is in comparison to the parent function, which is y equals x squared. So narrower or wider than that parent function. So then we get to play with this graphic and just focus on leaving A 0, leaving C 0, and seeing how B impacts our graph. So B is a little tricky. When we see our B, we see here we have a positive number, and we end up getting this line, which is a positive slope. And as soon as we move it negative, we also see a line that is a negative slope, right? So our B is the slope of the line through the origin. Alright, so this gets tricky because we deal with curves, and so we will see how this slope impacts our parabola, but it's a little different depending on every case. A positive b is going to be a positive slope, which typically pushes our parabola to the left, and a negative b gives us a negative slope, and that pushes the parabola right. Right? It's using the fact that we have a tangent line. So if we have a circle, a tangent line just touches that circle in one place. This slope is going to be tangent to our curve. So right now it's hard to see because we're only moving the b around. But if we think about it, it's a linear equation. When our a is 0, we only have a linear equation, and so that b is our n in mx plus b, but it's a little different when we have an a and a c. So in this case, it is the slope of a line through an origin, and we'll see how that slope relates to the parabola later on. And then the last thing we have is our c, so just focusing on keeping all the coefficients 0 but only impacting our c. We can see that if we move a positive c, our graph shifts up, and a negative c, the graph shifts down. So really, just like we had our b in y equals mx plus b, the constant was where our y-intercept was at. The same thing happens in our parabolas. The constant, or our c here, is representing or impacting the y-intercept. Okay, so a positive c is going to have a positive y-intercept. A negative c gives us a negative y-intercept, just as we saw in graphing lines. So really this does all relate to our y equals mx plus b. Alright, here the x term represented slope, which is the same thing we saw for our b term, or the b, which was part of our x term. Here, our b was our constant, which gave us our y-intercept, which is the same thing we're seeing in our quadratic. We just changed the variables a little bit for our coefficients. But here we still have the y-intercept. Here we have the slope of a line through 0, not necessarily the slope of our parabola. So the only thing we're really adding on is this ax squared, and this is where we actually get the curve of our quadratic. But everything else is the same as we've seen in the past. Right? So let's go ahead and look at how all of this is impacted. If we have a positive graph, and then we have a positive slope, all right? Now we can see this green line is representing that positive slope through the origin, and then we can kind of see that tangent that I was talking about, where that green line is touching our parabola tangent to that point, and it kind of shifts our graph over a little bit. And then our c is going to make it pop up or pop down according to our y-intercept. So we do see the changes in our graph depending on how we move our graph around and how we change the coefficients. So it's an interesting little simulator that helps us see all of the different characteristics of the coefficients. Right? But we need to be able to identify some key characteristics without having that simulator. We need to find the vertex, the max, the min, and the axis of symmetry. So again, real quickly, our vertex on a graph is either going to be the highest or the lowest point. So here we have, for example, a vertex. A vertex will be an ordered pair. Right? So this is going to be an ordered pair. Our axis of symmetry is going to be a line, and if we draw it in here, we can have our axis of symmetry, a little crooked. There we go. And it's going to be a perfectly vertical line, and so we know that any vertical line, our axis of symmetry, is a vertical line, or is going to be passing through our x, so an x equals line. So the formula we use to find this vertical line uses the coefficients of our quadratic. So if we want to find our axis of symmetry, we use x is equal to the opposite of b over 2a. And this is actually part of our quadratic formula. If you remember the quadratic formula, opposite of b plus or minus the square root of blah, 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 all over 2 times a. Well, we're just taking that front and bottom portion. So we find our axis of symmetry using this equation. Then, once we've found what this x value is, we can substitute it in to the actual quadratic to find the y value. So our vertex is the ordered pair, and we're going to use the x value that we calculated for the axis of symmetry, and we substitute that in and we get a y value out. So these are the two important key points from this unit. So let's try and do an example using this. So I want to find the AOS, that stands for axis of symmetry, and vertex for the following quadratic. All I have to do is, for my axis of symmetry, I know it's going to be a vertical line, so I'm going to use my x equals opposite of b over 2a, and I substitute the values from my quadratic. So I'm going to use the opposite of b, which is negative 8, over 2 times a, which is 2. Opposite of a negative is positive 8. 2 times 2 is 4. So my axis of symmetry is an x equals 2 graph. So now that I know my x coordinate of my vertex, right here I have a quick sketch. I know it's opening up because it's a positive graph. It's going to shift somehow, right? But great, looks something like that. I know that my axis of symmetry is going through 2, which means my vertex, if I drew this more accurately, would be at 2 over, and then I need to find my y coordinate. Well, I can just substitute this back in to find my y coordinate, which we represented as opposite of b over 2a y. Alright, so this is my x, so now I'm going to find the y. So I have 2 times 2 squared minus 8 times 2 plus 6, and I get 2 times 4 minus 16 plus 6, or 8 minus 16 plus 6, which gives me negative 2. And that's my y value, if we want to carry this down. So if my x is 2 and my y is 2, then my vertex is equal to the x coordinate and the y coordinate. So those are the two main things that you will be asked to find: your axis of symmetry and your vertex. You might also be asked whether it's a minimum or a maximum, and all you have to do is look at the front coefficient. So I know that this is a positive coefficient, which means my graph is opening up, which means my vertex will be the lowest point, so this will be a min. My vertex is a min. So it's just good to get an idea if you want to do a quick sketch to kind of help you visualize, and maybe you forget what to do to find your vertex. Draw a quick sketch and say, oh, I know my x, this is how I find my y. Let's do another example where they actually want us to tell whether it's a max or a min, and then find the ordered pairs. So they're not concerned about the axis of symmetry, we're just focusing on the vertex. So again, I can look and I see that this is a positive graph, so I know that it's going to be opening in a positive direction. So wherever my vertex happens to be, I do know that it's going to be a minimum again. So my minimum is going to be an ordered pair. Well, in order to find my ordered pair, I still have to find that x value. Even though they're not asking me for the axis of symmetry, I need to still find my opposite of b over 2a, because without this x value, I'm never going to find my y value. So I substitute opposite of b over 2 times a, and I get negative 8 over 4. So here my x is equal to negative 2. So I'm going to substitute that back into the original equation so that I can find my y. So my y is equal to 2 times negative 2 squared plus 8 times negative 2 plus 7. I have 2 times 4 minus 16 plus 7, 8 minus 16 plus 7, and I get y equals negative 1. Alright, so there's a few different ways to write this. If they want to tell the ordered pair, I need to use both my x and my y. They did want to know whether it's a max or min. So you can say a min at negative 1. And that's what they would say if they want to know the value of the minimum or the value of the maximum. You just say whether it's a max or a min and where that value is. So what your y value is going to be. But here they're asking for the ordered pairs. So we want to give a point. So we'll say the min at negative 2, negative 1. Okay, so both of these are acceptable. It just depends on how they're phrasing the question. So using this information, go ahead and complete these two self-check problems in your notes and come in ready to discuss tomorrow.